Hello, I am Tuğçe Aras. We are electrical and electronics engineer students at Marmara University, and this is our digital design project. Our objective was to design an automatic smart wiper system using the basis 3 FPGA board, integrated with a rain sensor for detection, a servo motor for the wiper action, and an I2C LCD for user notifications. We successfully met all the requirements outlined in our initial proposal, ensuring that the system is both responsive and reliable for real-world applications.
Hi, I am Yağmur Damlayınan, and I am going to explain states for our FPGA design. We designed a Finite State Machine with 3 states to classify rain intensity. First state is S0. This occurs when no rain is detected in the rain sensor, so the servo motor remains off. Next state is S1 for light rain. When the sensor value crosses the first threshold, the system transitions here, and the servo performs a slow sleep. Finally, state S2 for heavy rain. If the rain intensity increases further, the system switches to S2, where the servo performs a fast sweep. The transitions between these states are triggered by comparators that continuously check the analog sensor values against our defined thresholds.
This VHDL code implements the top-level design of our adaptive wiper control system on BASIS 3 FPGA. We first include the IEEE logic and numeric libraries, which allow us to use standard digital signals and perform arithmetic operations safely. The entity defines the system input and outputs, including a 100 MHz clock, the analog input connected to XADC for the rain sensor, a PWM output for the servo motor, LCD control signals, and LDD indicators. The rain sensor data is read using the XADC wizard IP core through the VAUX6 channel, which is physically connected to JXADC header on BASIS 3 board. The analog voltage is converted into 12-bit digital value and stored as rain val. Based on this value, the system classifies the weather into 3 states: no rain, light rain, and heavy rain. The bounce mechanism is used to prevent unstable state transition when the sensor value is near a threshold. The servo motor is controlled using a PWM signal with a 12 millisecond period. The duty cycle is adjusted to control the servo position and swap speed accordingly to the rain intensity. LEDs provide a visual indication of the current rain state, while on LCD, Finite State Machine displays a descriptive message such as no rain, light rain, or heavy rain. All modules operate synchronously with a system clock, ensuring stable and reliable real-time operation. In conclusion, this design demonstrates how an FPGA can integrate sensing, decision-making, and actuator control on adaptive embedded system.
Hello, I am Şerif Ayşe. Now, I would like to show you how our project works. Here is my hardware setup. We have the BASIS 3 FPGA board, the rain sensor, the servo motor representing the wiper, and the LCD screen. First, let's look at the initial state. The sensor is completely dry. As you can see, the green LED is on and the motor is off. The LCD screen displays no rain. This is the safe mode. Now, we will simulate the light rain. Notice the change. The servo motor starts moving at a slow speed, and the LCD now shows light rain. Finally, let's simulate heavy rain conditions. When the sensor gets very wet, the system detects danger. Most importantly, look at the motor. The wiper speed has increased significantly to clear the rain. The LCD displays heavy rain. When I dry the sensor, the system returns to initial state. The motor stops and the green LED back on. This is our rain project. Thank you for listening.